In this video, we're learning about plate tectonics, so we'll cover what tectonic plates are and how they move, how maps of ancient land and water patterns provide evidence of plate movement, and finally, how tectonic processes can both generate and destroy the seafloor. Before we can cover what tectonic plates are and how they move, we first need to recap Earth's basic structure, which is made up of three main layers. The outermost layer is called the crust. The crust is a thin, solid rock layer that forms the surface of the Earth. Then beneath the crust is the mantle, which is a much thicker layer of rock. Now, because this rock is so hot, it actually behaves like a very thick liquid, even though it's mostly solid. However, it's not entirely solid, and we refer to the parts that are molten rock as magma. Then, at the very center of the Earth is the core, which is subject to extreme heat and pressure. Now, if we look at tectonic plates, these are massive slabs of rock that make up Earth's crust and the uppermost part of the mantle. These enormous pieces fit together a bit like a jigsaw puzzle to form the Earth's surface, and this includes both the continents and ocean floors. In total, there are about a dozen major plates and several smaller ones. Importantly here, tectonic plates are actually constantly moving about, but it's very slow, normally just a few inches per year. Over millions of years, though, that means the plates end up traveling enormous distances. When continental plates collide, they push land upwards, which can form mountain ranges. On the other hand, when plates move away from each other, they can split continents apart. For instance, the Atlantic Ocean formed when a supercontinent called Pangaea began splitting apart about 200 million years ago. And in fact, the ocean's still growing wider today. Tectonic plate movements are also responsible for causing earthquakes and volcanic eruptions, especially along the boundaries where plates meet. Scientists can measure current plate movements using satellite technology, confirming that plates move at rates of a few inches per year. Next, let's look at how maps of ancient land and water patterns provide evidence of plate movement across great distances. Scientists study rocks and fossils in order to create maps that show a few different things: where land and water existed millions of years ago, and also what sort of environment it was. We can see where land masses used to be because we can find fossils of the same ancient plants and animals on continents that are now separated by vast oceans. As an example, the fossil reptile Mesosaurus has been discovered in both South America and Africa, even though these continents are now thousands of miles apart. As these organisms couldn't have swum across entire oceans, this counts as evidence that these continents were once connected. As well as this, by examining different types of rocks and fossils, we can also determine whether an area was once covered by ocean, desert, forest, or ice. For instance, coal deposits found in Antarctica tell us this frozen continent was once warm and covered with tropical forests. Similarly, marine fossils found on dry land show these dry areas were once covered by oceans. By using these maps of the Earth from 300 million years ago, we can see how all the continents used to be joined together in Pangaea, and this provides evidence that Earth's tectonic plates have moved vast distances over geological time. Finally then, let's look at how tectonic processes can generate and destroy the seafloor. If we begin with seafloor generation, this occurs at places called mid-ocean ridges. Ocean ridges are a bit like underwater mountain ranges, but where each side of the ridge is a different tectonic plate. Importantly though, there's a gap between the two plates, and so pressure from the Earth's mantle forces hot magma to rise up through the gap. As the magma gets pushed up into the ocean, it meets the cold ocean water, and so the magma cools and hardens into new rock. The newly formed rock pushes older rock away from the ridge on both sides. And overall, the process generates new seafloor. This process of the tectonic plates being pushed apart is called seafloor spreading, and it happens continuously at a rate of just a few inches per year. On the other hand, seafloor destruction occurs at ocean trenches. Ocean trenches are these long, narrow depressions. They can be several miles deep, and they form the deepest parts of the oceans. Now, seafloor destruction occurs through a tectonic process called subduction, which is where the denser oceanic plate gets pushed downward into the hot interior of the Earth. Because of the intense heat and pressure there, the tectonic plate melts and becomes molten rock within the mantle. It's important to recognize here that the tectonic processes of seafloor spreading and subduction are both happening at the same time and to the same plate. It's actually the movement caused by seafloor spreading that causes the other end of the tectonic plate to be pushed downwards into the mantle. Over hundreds of millions of years, the creation at ridges and destruction at trenches means the ocean floor is constantly being renewed and reshaped.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.